in our today's lecture, we are going to study about what are the forces or pressure acting on the body of dam. Basically, there are various forces or pressure acting along the dam body. Especially, we are considering about gravity dam. So, there first one we will discuss in our last session, that was sulfate of dam. Sulfate of dam will be considered as the body of dam which will considered sulfate. It is what sulfate of dam is the total weight of dam according to which of their specific gravity into mass of that whole body, or that triangular portion. In when we are studying our theoretical profile or elementary profile of dam, it should be a triangular. So it should be a triangular, and then when the forces acting on it, the force which is called as such kind of water pressure, and we will see, and such kind of their weight is we will donate it by W. Okay, so W is acting always on downward direction. So if you are calculating the it is a simple formula of calculating W. What is that is a mass into gravity, then it will be kg. Okay, so we are not going to calculate that those things, but in basically our mathematical formulas we will describe that self is not other than gw into bh divided by 2. So where is the and what about the consideration of w is nothing but the self weight of the dam. Okay, and about we are talking about g, where g we considered specific gravity of the dam and dam body, and w is acted as weight, and b is a base, w is act as base of dam, and where h is the total height of dam. And again other pressure we will see in this lecture, and the second is the water pressure. On the upstream side of dam, suppose we are this is a dam. Okay, this is upstream side, and this is the downstream side. Okay, okay, yes. And then when we see some amount of water we are stored here, this is a stored water up to a certain millimeter, okay. So what will happen when the waves of forces or water will arrive some kind of forces which are acting along the wall at vertically. Okay, so because of that water pressure, what will happen, it will be excess, then the body of dam should be slided. Okay, so we restrain that forces. So we are going to discuss about this, what will be overcome that sliding effect. So first of all, such kind of pressure we are going to study. This is what about the pressure of water. If we are going to calculate that water pressure, then it is the simple formula. As we know, in our school algebra we will study, or our dynamics, or mechanics, engineering mechanics, we will study about that formula. This is nothing but P is equals to WH square divided by 2, where the W is the weight of dam. Okay, and H is equals to height of dam, where the water pressure will go at this direction. Okay, and the self weight will be minimizes up to sliding due to its self weight, the under under the normal reactions, under the vertical reaction. Okay, so when the horizontal movement or what horizontal forces we say, they along this direction will sliding the dam will resist, the sliding of dam will resist it by resisting force of self weight of this dam. Okay, my dear friends. So water, this is all about water pressure. We will see this. Okay, and the third force which is acted on a body of dam, it is self pressure also. So what is the self pressure? Self pressure is the pressure at which the dam which is said which is collected at the topmost portion of the dam body. Okay, so what will happen, they will also arise some kind of forces. As you see, I will draw on next page. This is the body of our dam. Okay, so what will happen, this is our GL. Okay, and then what will happen if a certain amount of silting, deposition of silting will be there. Okay, so when in the flow of river, they are not only flow water, they are also some kind of silts and other things, they are flow through it, and all that silts are deposited on the bed of that river. Okay, so if you constructed that dam, then some amount of silt will be applied on the bottom of dam. So what will be happen, silt also generate some kind of force on the body of dam at the upstream side. Okay, so what will happen if they provide some kind of forces, but we can calculate mathematically what will be the value of that, or what will be the expression of that forces. So we will see what is the forces acting on that wall of the dam is going to we will consider it as it's about water pressure plus it's a passive earth pressure. Sorry, it's an active earth pressure. Suppose we consider that silt pressure will be P3. Okay, so what will happen? Water, we are not depending that water forces. It's just a silt forces up to the depth of somewhat amount of height we as we consider as h. Okay, and uh, and W is the weight of silt. In this we will see such kind of silt generate some kind of weight or some kind of mass up to different height. Okay, so suppose we will consider that as h. Okay, then the formula will be arised as the what is the water pressure. It's not a water pressure actually, it's a deposited area of silt. So what will be the deposited area if we calculate it? So WBH h square into S divided by 2 into what is active earth pressure in our term. Will if you are thinking about theoretically, then it will be active earth pressure. We will take in consideration. But otherwise, if we are going to calculate some sliding effects or other no tension effects, then we will not consider active earth pressure in there. But if we consider, as we know, this value is nothing but the 1 minus sin pi divided by 1 plus sin pi. And where is pi is the angle, where is it? Sin pi is an angle, it's a vertical component. Okay, and where W is a weight, where W is the weight of silt, B is base of silt, and H is the height up to which height the silt may be deposited. Okay, dear friends. So another parameter is there is S is a S will mention slope of silt. Okay, so it will be if we are going to calculate that values, we have to know such kind of values to calculate our silt pressure. And next one pressure is nothing but the and next one pressure is nothing but the uplift force. And what is the uplift force? When dam is resting on a foundation or any kind of soil. Okay, so what will happen when dam is rested on that soil? Okay, so according to thermodynamical law, that will say that is suppose it's the center of gravity of dam. Okay, it will acting and or its self weight through to downward direction. Because of the direction of forces, what will happen, the soil is also carry some kind of forces are there on the bottom body of that dam. It is the top of dam and it is the bottom of dam. So what will happen when the force is acting along vertical direction at negative component is called as uplift forces. Okay, so what will be happen if we think about that this is the heel of dam and it is a toe of dam. Then what will happen even when the force is applied over it? Then the uplift force is provided maximum at the heel of dam and minimum at toe of dam. Okay, so we will find out. If we are thinking about the mathematical measures, then the formula we will formulate the uplift force. We consider uplift force as a P3. We will consider it, and what will happen? The formula will be looking like that: KWB into H plus HA divided by 2, where K is the permeability of foundation, and permeability of foundation value will be varies between 0.2 to 0.6. 0.2 will be considered as hard rock without any cracking. where 0.6 is the cracking or cracked rocks. The value between that two will varies between types of rock foundation we will provide through the bottom surface, because if we are talking about overturning forces of the foundation and its act upward, it's all about that. It's a base of that foundation as we will saw here. Okay, so it is also exerts some amount of forces causing what the overturning of dam will be takes place. Okay, so we will see now. We will see fifth forces. There are too many forces acting on the dam. It's a tail forces, tail water pressure. If you are talking about more about tail water pressure, it's exactly what when it is a body of dam on. हा बोल ना दादा. अरे घरी होतो यार, ते थोडं म्हणजे लेक्चर्स काल परवापासून जे आहे ना मागे लागले आहेत. कालचं साला बिलाचं काम झालं, काल एक तर तुझा कॉल येत होता ते कट करत होतो, कारण की मेन म्हणजे आहे ना आपला याच्यातच होतो कामातच. काल मला 7 किंवा 8 वाजले यार घरी आलेस. त्याच्यामुळे काय भेटणं नाही झालं. हो, ते म्हणजे बिलांचेच कामं अटकले होते ना, का ते वेळेवर त्याच दिवशी बनवून द्या म्हणत होते. तर 7 आणि त्यातल्या त्यात पुन्हा आता एवढे दिवस सुट्टीवर होतो, तर कसा पोरांचा सिलेबसही थोडा मागे राहिला आहे. हा कसा ते आता कॉलेजमध्ये गेलं तर होईल ना कंप्लीट, त्याच्यामुळे घरीच बसून एक ऑनलाईन क्लासेस घेत होतो. नाही झाले नाही रे, करून राहिला ऑनलाईन कुठे कुठे. ते आता सध्या व्हिडिओ बनवून आता टाका लागत आहे ग्रुपवर. आता अशा गोष्टी आहेत भाई. अरे ते गेले आहेत कॉलेजला. त्यांच्या कसं त्यांचं काय तास राहते, महाग कसा डेली लेक्चर्स असतात, त्याच्यामुळे माझे वांदे असतात थोडे. हं? माहिती नाही यार, का करायचं होतं त्यांच्याशी. तू आहेस कुठं आता? अच्छा हो का, त्यांच्या समीर म्हणून नाव आहे. हम्म. मी मला यार माहित नाही, दिवसभर टाइमच लागेल साला. पुरा चॅप्टर कंप्लीट केल्याशिवाय तर मी उठू नाही शकत भाई. एक काम कर ना, मी आपला जसा झाला तुला कॉल करतो, तू आपला इकडे आरटीए चौकात येशील का? तिथं वायफाय आहे, तर वायफायवर मला अपलोड करावं लागतेस. हम्म. ठीक आहे ना. Because of that reason, we will always take a safety factor from the 1835 to 1993, which is a provision of IS 1883 into 1993. Okay, this is the IS record for earthquake resisting systems. Okay, so what will be happen? Then we will consider the, suppose we consider it's a seismic force PC. Then the formula will be arise 0.27726 CW, which is greater than H into H square, where C is pressure coefficient. Okay, and alpha H is equal to seismic coefficient. Then its value will be varied. Seismic coefficient value will be varied from 0 to 0.24, and the and value of pressure coefficient will be varied from 0 to 0.75. Okay, so that are the mathematical expressions for seismic forces. And if we are talking about other forces, why there are other forces are categorized in some kinds, like ice pressure, or also we will know him snow pressure. So snow pressure is what when body of dam is here, as we consider, then this is the upstream side, this is downstream side of the dam. When the water is stored over here at the extremely cold condition, what will happen? The formation of snow or ice will be takes place over the top surface of the dam, or it may be also bottom surface of dam, will be lesser, but top surface will be easily impacted with the environment. So it may be the slightly more possibilities of making snow on this area as compared to bottom portion. Okay. So we will consider the pressure of that ice should be 5 kg per centimeter square will be taken according to our standard criteria. And other second one is also wave pressure. Wave pressure is what? When the waves, this is the dam, and when the waves will generate on this type. Okay, it either may be L wave, P wave, secondary waves. There are many types of waves will be generated, and these waves do what? uh, Rest on the surface of the dam. Okay, it's a retaining wall of dam. Okay, so it will be acted along this direction, and maybe what it generates some impact on that wall or external boundary of that wall. Okay, so this is what it also arrives such kind of pressure which affect on dam. So what will happen will be also take in consideration while we constructing a dam. Wave pressure is also one kind of pressure which is generated by water bodies. Okay, so wave pressure as we taken for our safe construction measures, we will taken wave pressure 200 hw kg, where h is the height of dam and w is the height of wave obtained. Okay, so and the third pressure which is we count in consideration is wind pressure. So according to wind pressure, the if we are going to construct the body of the dam, okay, we will see it on detail. If this is the dam body, this is upstream side and this is a downstream side, when the force of the or direction of air will be in this place or will be in this place. So whatever. Okay, so what it such kind of forces is also provided, so we will take it. So wine pressure is also minimizes, but at what a certain demand or what a kind of that other things we already studied about it. Okay, so this is also a generate on the wall of that area of our dam. So guys, those are all forces we are studied on this lecture. So such kind of pressures we will study on this lecture. Self-head of dam is one of them. Second one is a water pressure. The third one is a silt pressure, and fourth one is a uplift pressure. Fifth one is tail pressure, and sixth one is seismic forces, and seventh are other forces, which will further categorize into ice pressure or snow pressure or wave pressure. And second one is wave pressure, and third one is wind pressure. Wind pressure should be minimized, or it's more less, or it will we will neglect this pressure also. In our syllabus there are not mentioned the value, or it's not mentioned according to their design criteria, according to their IS codes which are prepared on construction of dam sites. They will mention the value over here. Okay, so we add that all kind of forces which are acted along the direction or the body of dam, then that forces will be considered when designing theoretical as well as elementary profile of the dam. And what is the elementary profile of dam? Elementary profile. What is the elementary profile? It is a cross section of dam. Suppose we are constructing. Okay. So what is the elementary profile? So elementary profile, where it's an suppose these are the dam. Okay. We are going to construct this dam. We are going to construct. So what will happen when we are considering that the cross section area of entire dam. Okay, cross section area of that entire dam for the maximum height of dam about the rock foundation. This is the foundation as we mentioned here. Okay, some kind of it's a pile foundation or some kind of a submerged area will be there. Okay, so this is the GL we will consider. So what will happen when the body of dam is a construction at the foundation? Okay, so what much amount of base we will provide through providing of some kind of sliding forces or tensional failure or even compression failures and other minor failures to prevent that forces to prevent from that threats, to prevent from that threats, or to prevent from that other disasters, such as we will do what? We will study the theoretical profile of dam. Elementary profile is also known as theoretical profile of dam also. A theoretical profile of solid dam is imaginary section having only the shape of the dam will be taken in consideration, and according to that shape we will study the whole the geometry of that section. If we considering any dam section where this is a we will consider this is the base of the dam, and this is the height of the dam. We will consider h, and we will consider base b. Okay, so if we consider this thing, then there are we considering three forces. Which of them? Horizontal forces and vertical forces also. So first pressure, as we discussed in our last topic, this is our self weight of dam. Okay, self weight of dam which is acting at the downward side. Okay, this is a self weight we will consider is as a w. Okay, so and the second force, as we studied here, this is a water pressure. Water pressure is also considered, it's a main pressure. So what will happen? Water pressure, if we see this dam is on this side, the water pressure is also created there and obstruct on the layer of external facing wall, sorry, internal facing wall of the dam. Okay, then water pressure is also there, and some kind of forces which are acting on the body of dam, which is on that height will be acted on what? Height will be acted water forces or water pressure, and base will be acted as self weight of the dam. This is the self weight of the dam, and which was acting along the base of the dam. Okay, so because of that base, because of that acting some downward force, or maybe we can say self weight of dam, some kind of uplift force is also generated. So so what will happen then? There are we can if we are number it, those kind of forces. First force is water pressure, second force is self weight of dam, and third is nothing but uplift force which will be provided on the body of dam. Okay, so if we are talking about that forces, we will take numbering from that forces. Okay, so coefficient, it's a permeability of soil has been taken. Okay, so this is the net vertical forces we will get. Okay, so there are vertical forces. Then first of all we studied net vertical forces which are acting along the body of dam. Okay, and there are two conditions maybe arises on the body of dam. This is the body of dam. Okay, so what will happen if the water pressure will be maximum? Then what happen? Then then the whole body of dam will be sliding. Okay, to minimize that sliding, we will do what we will generally did that we will increase the summation, we will increase the self height of that dam. But at that time we are going to what percentage we are going to what percentage of dam increasing their base or their height at the respective level. We will do what we will calculate no tension, for no tension condition. As we know, concrete body, if we are made an earthen material or concrete material, as we know concrete is weak in compression. Is sorry Concrete is weak in tension but high in compression. Okay, according to that phenomenon, what will happen? They are fail in tensioning. So minimize that effect at what percentage or forces or what percentage of movement that will fail, that will be studied there. If we could minimizes the tension, then what will we do? We just do some kind of tensioning force is there. We will tension force. इसका this is plus minus sign. We are doing plus minus about re- restricting force. It must be zero. Restricting force or all or other parameter, we will say that restricting force or resisting force also. Okay, so that must be equal to zero. Then what will happen? The no tension condition will be satisfied. So because of this condition we will have to satisfied. We will do what? At the mechanics, simple mechanics formula. What will we do? let's see, this is the dam. Okay, so this is the body of dam we are showing here. This is the forces acting on it. We will consider at P, forces which will acting on the surface of the body of dam, which is P. Okay, so P is the force, and forces which is acted along what size. So along what size we will see it's always acting. This is a H. Okay, so if we are categorized into three parts. So okay, so what will happen? Let's see, this is 1h, it's 2h, and it's 3h. So h by 3, h by 3, and h by 3 distance. Over it, so maximum force will be generated on the body of dam will be on h by 3 distance. So h by 3 distance we will be getting in consideration. Okay, so first of all, the force which is acting on the body tensioning condition will be get what? First force is tension force. This is for tension force, and as we know the force criteria, wl square divided by 2. So in this thing, our L we will consider, or we will consider, for 2 is for pressure, is not for this. We will consider P into H. In terms of length we are taking H, but H we are because of what? At H of P, H by 3, H by 3 distance is the total length of dam where the resist tensioning force will acted on the dam body. Okay, so the tensioning force is what? This. And resisting force, if you are talking about resisting force, will be the weight of dam minus upthrust force or uplift force divided by b by 3 length. Because in what terms we are getting h by 3 distance, we will also get b. This is also divided into three parts, or this will also divided into three parts. So what will happen? The b by 3, b by 3, and b by 3 distance. Okay, so this is h and this is b we are talking about. Okay, so what will happen? B by 3 distance, then net resisting force for no tensioning. What will happen? We will have to, according to this formula, we have to put that both values. Okay, resisting force, and this one is tensioning force. So what will happen? No tensioning condition, P into H by 3 minus W minus U B by 3. It must be equal to 0 whenever our forces of equilibrium will be satisfied and no tensioning condition will be happen or arises. So we will further simplification that formula. We will get what? B is equal to pH minus W minus U. When we shifted that whole terms, let's see, I will show you. P into H by 3, when that whole terms is go, then we will get what? We will get W minus U divided by B by 3. Okay, so we want what? We want the B. So what amount of width we will provide, what amount of width we will take in consideration for net no tensioning. If our base of the dam will be safe, if this base of the dam will be safe, which will be safe to construct that all sliding forces or tensioning forces to resist. So we will designing for the base of that dam. So what will happen? We are taking consideration of B. So if that whole terms will be going through it, the value of B will be the value of B will be get P into H divided by W minus U. Okay, and is equals to the notations of W H square divided by 2 into H square WBH into G minus K, where K is the permeability of soil on G, and G is the specific gravity of the dam. Okay, so this is the condition. We will further subdivide it into it. We will get what? We will get H upon under root G minus Ks, or in this term we will get the value of our B. If we have to have gonna design for no tensioning condition, so we must do some kind of restriction. We have to provide base width of B is up to height divided by under root of specific gravity and multiplication of coefficient of permeability and sloping width of the dam. Okay, so again second condition is also arise, and this condition is no sliding. In this condition, when the body of dam will be when the water pressure is acting along the wall of the dam. Okay, so what will happen? The sliding condition maybe arises. this is first condition as we see in the dam. This is tension condition, and second one is no sliding condition. So if we are going to do about what will happen when the whole dam of having height h. Suppose we are going to consider the height of the dam is h. Okay, this is the height of dam, and b is the base of dam. We are taking consideration for no sliding. For no sliding, what will be happen? The net force when we will minimize the sliding. Sliding is not about but all horizontal forces. The summation of h plus minus summation of v is equals to 0. Then what will happen? Summation of h and summation of v is what? Net vertical force and net horizontal force, or in terms of what? Net horizontal forces towards the sliding, or we will also take resisting force also. Force. Okay, net resisting force and plus minus horizontal force will be 0. Then it may be minimizes. Okay, so factor of safety in terms of this we will get 1. We will consider for no sliding. So what will be happen in this is, suppose we are considering horizontal forces, and net resisting forces is equals to and as we consider resisting forces are what? Resisting forces are simple plus vertical horizontal forces is what we are taking consideration. This is our water pressure. Okay, only the water pressure will be acted along the y direction. So as we gonna look at it, we will see there are vertical forces. Okay, vertical forces are presented by what? They are self-made of dam, and the uplift force of dam, they all are vertical forces. Okay, so if we are talking about the horizontal forces, there are horizontal forces are only two forces, only one forces, and this is what? This is the water pressure which is exerted on the interior side of the dam. Okay, so in that thing only water pressure is there, and we know what is the water pressure. Water pressure is nothing but w into h square divided by 2. In terms of what, we can write w as a p also, ph square divided by 2. So this is all about horizontal forces. Okay, and if we are talking about resisting forces, if we are talking about resisting forces, we will get what? Some amount of summation of vertical forces minus some amount of friction is also generated here with the contact of a dam surface, dam base, and with the contact of the soil base. So if we are taking consideration, mu is a coefficient of friction. Okay, if mu we are taking the coefficient of friction. Okay, so we vertical forces minus the frictional coefficient. Okay, so divided by horizontal forces which are restricted to it. Horizontal forces is what? Some kind of a, let me show you, some kind of passive earth pressure related to that soil also, or vertical some kind of forces we will take in consideration horizontally, that it's a wall that are also retaining that are also doing some kind of pressure are exerted on it. So such kind of pressure diagram are there. Okay, so this is also there, some kind of horizontal forces is also there. So what will happen? The net horizontal forces will be, see that the equation becomes our, if we are putting these values on these equations, on this condition, if we are going to put that values, we will get what? We will get this is summation of h is equal to summation of v minus u. Okay, summation of v minus u into coefficient of friction. Okay, this is the u is taken as